Alspace is running way better than VRChat on Quest.
Yeah, but for the
really
presentation, you
better.
should probably just use the computer because otherwise it'll just get overheated, and you want to use that like for the actual like social
Not sure if I want
interaction.
to use that with VRChat. We'll see how this one. But will my
How is
headset
everything?
overheat? What's that?
Everything's good.
Well,
Doing a
not
lot of
overheat,
business right
but I
now,
guess
huh?
I don't
Ooh,
know,
Seen
run out
you.
of battery or like get
I'm
uncomfortable.
plugged on
Business.
on
What
a
kind of
wall.
business?
I have a
Because
fun
you have new Twitter handle
at me,
from stores and stuff.
so
Yeah.
I don't know. Why do you need the
I'm
headset for the presentation itself?
I don't know. I think it's this summer.
to say
I
hello,
need to create new accounts and
Hmm?
do stuff, and
to
I'm
shake hands.
helping
hello.
a guy who
Yes.
is
No, because you
Handshake.
can't. You're not
doing
supposed to.
photography.
No, during the
So
presentation
I want
itself.
him to have more
During the
exposure, and
presentation, I
I'm
don't. But
moving
I
my
just
shop.
wanted to try it
So
out.
I'm
because,
thinking maybe if I'm
Mhm.
going online
as you see,
to do like an online shop,
but
No,
then
not
maybe
now.
I
Now,
start
yeah, now
also,
hang out with the
you
Quest.
know, waking up a little
sounds
bit
good.
and be organized.
I won't switch over in the middle.
Because otherwise I'm
Anything.
gonna have like a whole
So
room
we'll see.
full of
hi.
stickers.
It's annoying.
Hey,
But
so you finished
And,
the...
I see you.
yeah,
Hi.
Yeah,
that
you
will
finished
be
the
it.
campaign,
So
huh?
I think it's
on
better
the,
to have
night
Twitter
series,
I heard
accounts than
nothing
too
from
many
TCP.
stickers.
doesn't
There's
blow my
nothing
eyes
going
Yeah.
on.
It's a little bit more.
You're
Yeah.
so quiet.
Plus these days they've
You
been
should make
doing a lot
yourself
of
louder.
promotion. I don't know. You receive
Wait.
all of
Well,
them, right?
I can see that
Yeah.
Like
rivalry
Elena
is going to be...
I have
The-
several
Is
accounts.
it any better?
They're always spamming.
Oh, I
think
just
so.
I
started
know,
trying.
but it's
I
so
just tried
crazy
out
because they're like,
Yeah,
oh,
yeah,
now we're
Moz.
doing
Oh, yeah.
the
Night
transparent
setting,
one. And I'm like,
Moz is pretty
yeah,
good.
but
it's
I'm
way
not
better.
ready.
Yeah,
Pretty good
I want
visuals.
a design.
yeah.
I don't have a
Yeah,
design.
yeah.
It's
Wait a
little bit
second.
more
And then the
impressive.
next day they go like,
Nice.
well,
But I didn't
forget about
really
that. Now
feel
we're doing
like...
the round ones. They're like, yeah, wait.
It's
I
weird
need
how it
something.
didn't really explain
Okay.
I'm
so
always
you
Black
get
everything
screen
ready.
is
Send you
loud.
the link.
Just
Yeah,
wait
exactly.
I
Deal.
untoggled the stage blocker.
I'm just guessing
Gotta
You
work
need-
on
you
your
need to have,
preparation.
mechanical
What?
of the
Yeah,
Are you
game.
gonna?
Yeah.
You
You have
an
to
intro,
work,
or should I just introduce
work
myself?
on your
That's a bit strange.
preparation.
I know.
Yeah,
I need to have more
yeah, I
designs.
like part of the game to
I need
figure
to
out
have more designs
what
always
are your
ready.
powers.
Yeah.
Right.
So
you're all
I
set?
suppose so.
always
Yeah.
have a meme
Yep,
ready
that's
to-
good.
Yeah, so I only tried it for like 1 hour, but it looks
Yeah,
cool.
but you're out of control
Yeah,
now with
it's not
the
like
with the
it's
what is
like
it called?
more like
Deepfakes.
experience.
Okay.
with
I
game.
Yeah.
We face.
I played the room VR. It
but
was
is it
fun.
online or an
That's
app?
beautiful.
Yeah.
Okay, that's it. You're muted. Stop talking. Everyone stop talking. Just sit down. Cool. Okay, so if anyone doesn't recognize me, I'm Udi Wertheimer, and this is Reckless VR. I actually really missed you guys. It's been 2 weeks since we've done this. We usually do this every weekend, so it's cool to see you again. And for anyone watching this for the first time, you should know that we're doing VR meetups every weekend. So you can watch on Twitter or on YouTube, and you can get notified about future events by joining our various like channels. So there's the Reckless VR Telegram group that you can join. There's recklessvr.com where you can sign up and get emails with invites to those events. And we have reckless_VR on Twitter. So you can join any of these and you'll hear about our next events. Behind you over there's the kind of camera that shoots the video, so you can wave and just try not to obstruct the view. And also try to kind of stay in your place. I always say this, but try to stay in your place and don't move around too much, because it could be distracting if you move around too much. And yeah, that's it. So today we're joined by Jeremy Rubin, who's he's a Bitcoin core contributor, and he's the co-founder of the MIT Bitcoin project, and he's actually involved in a ton of other cool stuff. And he's also championing BIP 119, which is up CheckTemplateVerify, which is pretty cool. He's going to tell us a bit about that, and also how it allows for like new cool types of smart contracts. It's pretty cool. And I'm not going to spoil it, so I'm just going to invite Jeremy, and he's going to tell us about it. Hey, Jeremy.
Hello. Hey, everyone. Thanks for coming here with your Saturday morning. Appreciate everyone making it out. Today, I'm going to talk to you and give you your first class, Sapio Programming 101, how to build stateful smart contracts for Bitcoin with CheckTemplateVerify. So buckle up because there's going to be a lot to go through. So who, what, where, why? As Udi mentioned, I'm a Bitcoin researcher and developer. Came from MIT maybe 5 years ago from the start of the Digital Currency Initiative, and have been working as a core contributor for the last number of years now. I'm working on a new organization called Judica, which is an organization devoted to Bitcoin research and development. And the first sort of big project that I'm trying to release out of that organization is Sapio, which is a new paradigm for Bitcoin smart contracts. We're all here in VR, which is cool. I've never done a VR talk before, so we'll see how it goes. And why are we doing this? Well, I think that we need a lot of new things. That when we say Bitcoin fixes this, it actually means what we think it means. So that's the hopeful motive here. All right, let's do a little bit of basic background before we get into the main part of the talk. Who here, you can just kind of wave your hands or clap or something if you know about CheckTemplateVerify at all, or if it's a new concept for you. I guess so. That means that people have heard of it. Cool. So if you haven't heard about it, CheckTemplateVerify is a simple covenanting system for Bitcoin. What does that actually mean in practice? It means that CheckTemplateVerify allows you to do some more advanced type of smart contracting. And the actual specifics of the opcode are that, I'm just going to adjust my screen here. Okay, sorry about that. So the specifics of it, it is a new opcode inside of the Bitcoin scripting language that allows you to specify an exact set of transactions that can spend a coin at the time that that coin is created. So these scripts can sort of recursively commit to what the next transaction is. So you could have a coin that says go from coin A to coin B, and then from coin B to coin C, and coin C to coin D, and you can have an entire flow of a step of a number of transactions that a coin is going to participate in. There are a lot of use cases for this. It enables a lot of functionality. You can do things like congestion control. There's smart contracting, which we'll talk about today, and there's a lot more that you can do. This talk in particular, we're not really so focused on all of these use cases. We're more focused on Sapio, which is a smart contracting language based on CTV. So we're just going to be going into the specifics of how you actually might end up using this in practice, rather than everything that might ever be possible. So if you're kind of going well, yeah, this is a new BIP, so this stuff is useless unless we're going to have changes to Bitcoin. What I would point out, and this is maybe for the more, technically minded folks, is that you could make a CTV emulation oracle that would give you a lot of the same functionality as CTV, but with a different trust model. You'd have to have either some multi-sig federation servers that you trusted, or trust yourself to delete a key, but you can do something that's very similar to CTV without adding any new features to Bitcoin. So this language and way of thinking is general to either CTV or some trusted emulation service that maybe you're one of the participants in that federation. So you can think about these designs more abstractly and think of CTV as a way of making this much more accessible and usable by anyone. So this talk in particular, I think, as I mentioned, we're going to be completely about concrete examples. I don't want to just lay out some really big abstract design and tell you all the features of the language. Instead, I want to work through an example so you can kind of see end to end how you actually might use this in practice. The goals are to get excited to use Sapio, to get feedback on how you might use it. So to say well, I want to do this and it looks like this might not work, or I want to do this and it looks great for that. And just to teach you the very basics so that if you wanted to start playing around with it when it is fully open source and available, then you'll be able to know what you're doing a little bit. Non-goals, I'm not trying to cover absolutely everything exciting. This is a 101 class. We could go for hours and hours and hours on this stuff. So just treat this as an introduction, and at some point later, we can do a deep dive. In this talk, we're going to use Liquid, Blockstream's product, as a parable because it's a relatively, compared to what else is deployed in Bitcoin, sophisticated smart contract. People are generally familiar with it, And it's actually something that really highlights a lot of the strengths of both CTV and the Sapio language. So we're going to use this as our main example and explore this throughout the rest of the day. So if you're not familiar with Liquid, it's essentially Blockstream's like sidechain where they kind of have like an alternate universe of UTXOs that some group of people run servers to allow you to shuttle coins back and forth from Bitcoin and Liquid. So the contract that we're focusing on is the mechanic for shuttling the coins back and forth and how those coins are managed. Right now, the Federation managed funds live inside of this script. So if you don't read Bitcoin script, all this is saying is that you have 11 out of 15 of these men who are doing some sort of multi-sig, and they're allowed to move the coin however they want. And the idea is that you need 11 people to be dishonest in order for the funds to get stolen. And you need 5 people to be dishonest in order for the funds to get frozen. So what happens if the funds get frozen? Well, then you have another case which says, or we can wait for 4 weeks. That's 2 weeks. That's 4 weeks worth of blocks, and then we have some bit of backup keys that we're also going to do a multi-sig with. And so in Liquid's case, you have this 11 of 15, and then Blockstream has a 2 of 3 that is managed by some of their most important employees. That it's not actually public who manages it, but it's people who are maybe well respected and you would trust to make good security decisions. So that's the basics of how Liquid works for the functionary system. But this is kind of low level. So we're looking at this contract, and it's in this Forth language, which is hard to read. And so Blockstream, they came up with this thing called Miniscript at Blockstream and other people in the community as well. And what Miniscript does is it allows you to lift this up into a higher order language that is maybe a little bit easier to read. And so now we can see the same structure where it's multi-sig of these watchman keys, 11 out of 15, or a multi-sig and a timeout with 2 out of 3 of these keys. Now, there's kind of some funky business going on with this OR C and V. You need to know really specifically what output you're looking for when you're using a Miniscript. It's designed to have sort of a one-to-one mapping between this description and this script and back and forth. So if you have the script, you can generate this. If you have this, you can generate that. There's another language, which is called policy, which sits at a level above that. And it just says, let's think about the abstract idea of ORing 2 things together and ANDing things. And you can describe the same sort of thing, but without worrying about the internal details of how it's represented. And so policy compiles to Miniscript, which then compiles into bare Bitcoin script. And this is right now the state of the art for how you would write a Bitcoin smart contract. What I'm introducing with Sapio is a new layer on top of this stack. And this layer gives you a Python, basically interface into being able to write a smart contract. So what you can do is you can declare this Liquid as a contract. You can give it a number of fields. So it has a set of keys and a threshold for all of them, a set of backup keys and a threshold for the backup, and a total amount of coins that are being sent to it. And then you can write out the different pathways. So there's an unlocking condition, which is the Federation spend, which requires everyone to sign, or 11 out of 15 to sign. And then you have a backup case, which is a backup threshold amount and backup keys, and then you have to wait for 4 weeks. And so the idea is that this is even easier to understand and reason about and build tooling around than policy was. And so what we can do to just sort of make this concrete is we can look at this compilation pipeline. So we start with the Sapio that I just showed you. Then we go to policy. Then we go to Miniscript, and then we go to script. And if you look at what we've written out here, we saw on the previous slide, what this was. It's maybe a little bit too small. I don't know. Are you able to read the code on the previous slide at all? Is this too hard to read? Okay, cool. So what we have here is that script gets compiled to a policy, which looks familiar to the one that we looked at before. I've highlighted in colors the things that are the Federation spend or the backup recovery parts. So you can see what corresponds to what. Then we have Miniscript, which again looks familiar. So we have the backup case. And And then we have the script, and then the script is sort of the same thing as what we looked at before, but now it's it's coming from this Sapio language. Is that clear for everyone? Maybe good. Okay. So essentially, it's just like a new little front end, and you can write scripts in Bitcoin. That's kind of hard to do. So Miniscript and policy make that easier, and then Sapio just adds another layer on top of that. So recently, there was a, we'll call it a bug in how Liquid worked. So we had this contract, which we wrote out in the Sapio. And the idea is like these are representing blocks. And so you put that contract, you open it inside of this block, number of blocks go by, and then, oh, wait, this over here, this 4-week condition has now been triggered. And that means that after this coin has just sort of sat for, 32 blocks, like now the backup federation can actually move the funds. And so this was not really supposed to ever happen. The funds were supposed to just be moved automatically, like before the 4-week expiry happened, but that didn't happen. And as a result, people are arguing about the severity of this because, ultimately, like, is Blockstream an untrustworthy party? Like, probably not. But it was sort of outside the model that people were expecting of Liquid, where Blockstream would never actually have control of the funds. This happened sort of repeatedly and often. So what does Sapio and CTV do about this? So what we can do is we can take our contract, which this is basically the same contract as before, and we can add a new contract around it. So this is like a big slide, so we're going to take a little bit of time here just to read through what's going on. So we have this new contract, which is a federated pagan, has basically the same fields. And now we have a few different cases. So we have this normal case, which this should be called federation spend, which is the threshold of all the keys. And then it's the same as what we had before. And then we have two new things. So one, we have a requirement. So this requirement is not actually enforced, just like a declaration of a variable. It's just saying, here's a requirement, and it's called backup start. And this is when we have all the keys for starting the backup, set and required. And then here's where the new magic comes in with CTV. We have this new decorator, which is guarantee. So when we say something is unlocked, that means that whoever has, satisfied this condition can spend. But when we say guarantee, it means whatever transaction is returned from this functional block has to be the next transaction. This is using CheckTemplateVerify to guarantee that this transaction template is the next step. And so what this is reading as is saying that when the backup providers agree that the backup should start, they do a transaction which moves the funds into this backup operator. So the contract gets opened up here, which is the same one that we had before. So how does this fix that bug? So first, sorry, a little hard to see exactly what order my slides are in. But so the backup operator looks familiar, as we said, like it's the same thing that we saw before, basically the same policy and script output. The federated pagan, which was that new contract that we opened up here, looks a little bit different. And so the new component that we have is instead of just saying a timeout, we're saying that there is a transaction template that we have to go through. And that basically substitutes out where we used to have a timeout. We're now checking that the next transaction matches an exact template. So how does this actually fix it? We have a diagram of how the coins are moving. So circles represent coins, squares represent transactions. We move the funds in from somewhere into our pagan UTXO. And I guess I should use a pointer here. So we have the funds here in our pagan. And then if we have 11 out of 15, we can move the funds into some peg out transaction. If we have a 2 of 3, then we can start this backup process. And then once we start this backup process, we can either go 11 of 15 to peg out again. So the funds at all times remain within the purview of the federated, like main parties. But then if the backup operators have claimed that the federation is dead, then they have they need another 2 of 3 signature and 4 weeks to get to this backup UTXO. So essentially what we're guaranteeing is that as long as the funds stay here within this pagan, we will always have at least 4 weeks of time in order to respond to a claim that the federation is dead. And that means that these coins, once they're in the federation, don't need to constantly roll over. They're safe staying put just where they were. Does that concept make sense to everyone? Okay, so we've got some thumbs up, some some clapping. Okay. Oh, let me shut that off. Okay. So now, one thing you might say is, well, what if we want the funds, once we've gone into this peg out, to go back into the peg in? So what you'd be saying is like, yeah, it's not enough that the funds go into a transaction that pegs them out. Like, we want to know what we're supposed to do with them after we've, taken this step. So Sapio has your back here again. And now this one, I'm probably pretty sure people can't read that well. Can people read it? Yeah, okay. So it's okay. We're going to blow it up and make it bigger. Part of the purpose is that, I need to show you all the code, but it's going to get smaller so that it gets, or it's going to get bigger so you can read it in a bit. So essentially, what we have here is the same contracts that I showed you before, but we've added 2 blocks of code. Let me grab the pointer here. But we've added a block of code here and a block of code here. And it turns out that that is the same block of code. And that's on the contracts that we had before. And all that we've done is we've changed this federation spend path to something that looks a little bit different. And what's different here is it's been wrapped, and you probably can't read this, but it's wrapped up here with a new wrapper that is not just unlock, but it's called unlock but suggest. And what that means is this is unlock. So this transaction that we're returning out of this template is not guaranteed, but if you pass in arguments into the function, it will tell you what you're supposed to do. So it says the recommended next transaction for the federation operator is to take out the appropriate amount of funds for the users who have requested a withdrawal and then put the rest back into a liquidation. So this allows you to define sort of a stateful contract where once the federated operators have made an action, their default next step is sort of predefined within the scope of the contract. So it's known that the federation operators should take the relevant amount of funds out and then put them back into another instance of the contract. Does that concept kind of make sense? That it's just telling the operators what they should do, but not preventing them from doing something bad if they wanted to. Cool. So this is where the talk really becomes about, like, it's not a liquid talk. And so if you're just having trouble understanding like the liquid related stuff, that's sort of like, that's just general Bitcoin contracting. At this point, we're kind of focusing more on how Sapio works and what the language lets you do and why it's so powerful. And so what we're going to do is we're going to dry up our code. So we said before it was a really big block of code and it was too hard to read. Now we're going to dry it up. We're going to like put the functionality in one place, and then we're going to turn it into something really compact and readable. So why it just showcases how powerful Sapio is and what people are going to be able to do once this becomes a more mature platform. So the first thing we're going to do is we're going to take out these 2 common bits of code, and we're just going to move to helper function. And now, instead of having those blocks of code replicated in both places, now it's just like in one spot. And so that's a bit better, right? So like this is now less lines of code. Hopefully it's a little bit easier to read on the slide, but it's still like too much code. So the next step is we are going to combine these 2 classes that we had. And this is sort of like why we're calling these stateful contracts. We're going to combine these 2 classes into a single class factory. So a class factory is basically a function that emits instances of a contract and does some sort of conditional compilation. And so what we're doing here is we're taking both the backup step and the main introductory step, and we're putting this inside of a single class. And then we are adding conditional compilation, which you can see down at the bottom there, that says, depending on which state we are in, add one function or the other function. And so now we're going to, zoom in on this, and you can see it's sort of like a much cleaner representation. We'll zoom in on the interesting part. So now you can hopefully read it. What we've done is we've said that if the state is normal, then we are going to have just like a regular backup step. That's the first step in our process, where we said the 2 of 3 backup operators claim that the federation is busted. And then if we're in a state of recovery, then what we're going to do is we're going to allow finishing the backup, but require that 4 weeks are waited for. So require that there's appropriate time for the federation to respond and say, no, wait a minute, like we are still alive and this is an attempt by Blockstream to steal the money. So what this kind of showcases is that Sapio is a generally pretty powerful and flexible language for defining Bitcoin smart contracts and actually getting a compiled output that matches what you'd want. And CTV adds a layer that enables a sort of like guaranteed step, which helps fix sequencing and timing issues in smart contracts that you might write. Does anybody have any questions that they want to ask right now? There's like a second part to the talk, but I think now is the time to just take some basic questions. Okay, I don't know.
Right. So if
How to-
anyone want to ask anything, then you should have a raise hand button show up, and you can just click it, and I'll let you ask.
And there'll be a time at the end to ask like more general questions too. But if you feel like there's a conceptual block you have, it'd be good to address it now.
Okay. Yeah, I don't see anyone
Okay.
raising their hands, so I think you can go on, Jeremy.
Cool. So what else can we do? What if we really want to just go bananas? Like, how far can we take this concept? What types of contracts can we make? So the next one I'm going to tell you about is Tic-Tac-Toe. So this is the code. It's actually pretty easy to read. And what this does is this enables a game state for Tic-Tac-Toe. We have like some state machine, and it transfers inside the contracts, and then it's actually going to be completely secure and allow you to play Tic-Tac-Toe with anybody on the block. Oh, canceled. Nope. So you can do that in Sapio. It is possible, but in the scope of this talk, like I'm just showing that as an example of you can do a lot, but it's way too complicated. It's a little bit difficult to explain. I'm not really sure why anybody would want to play Tic-Tac-Toe on Bitcoin. The purpose of that is just showing like, yeah, this language is really powerful, flexible, and we're going to be able to do a lot. So no Tic-Tac-Toe for now. What else could we look at doing that is actually like a little bit more concrete that people might want to do right now? So there are option contracts, coin joins, wallet vaults, fundraisers. You can do stuff in the Lightning Network. There are games. There are payment pools. You can do wills, escrows, blind merge mined chains, congestion control, subscriptions, and even more. There's just tons and tons and tons of applications that you can build with the combination of CTV and Sapio. And for this talk, there's just like so much to do and so little time. I would really like to be able to present all of these to you, and maybe at some point in the future, we'll be able to go for an entire hour on each of those applications. But I think it's better instead to just go deep on how the framework works so that you can start thinking about like how you might actually solve real problems with it, rather than just sort of high level flyby on like a bunch of different topics. So we're going to continue looking at Liquid. And we're going to start with, kind of furthering our journey into Sapio by thinking about fees. So the most boring thing, but like everybody has to deal with it. So let's look at how fees get handled in a CheckTemplateVerify Sapio contract. So the best way to handle fees is to properly estimate them. So when you make a contract, guess how much fees you'll need in the future, and that's how much you should include. The problem is if you have a contract, and this is an issue that like Lightning Network and other multi-step contracts face, you have to guess the right amount of fees by the time the contract actually goes out. And if you had a contract which says that this thing can only happen like 4 weeks from now, and it only happens 4 weeks from like when a claim is made that a federation is dead, it might actually be like 2 years later by the time you're actually running this transaction. And so just estimating the fees is probably not an appropriate solution for long-lived contracts. So if you look at a simple contract like this is just like a very short basic example. We have a fee example. All it does is guarantee that the next transaction moves 1 Bitcoin to some pay-to-SegWit address. So we have some CDV UTXO, and then it has some transaction it participates in, and then that moves the funds to some 1 Bitcoin location. If you wanted to pay fees from this, the right answer is to just use child pays for parent. So what you do is when you have this SegWit address, when you want to actually use it, you have to do a new transaction, right? So if you want to use a coin, you have to do a transaction, and then you just pay some fees out of that one, and then that goes and subsidizes up the tree and covers the whole amount with fees. And so then the mempool will be able to recognize it all and accept it as like one high value package. So that's like the basic way that fees are handled right now in a lot of cases. You can use this wherever you want. Now, when you go to use this, what it looks like is you would add maybe some other output to this transaction, maybe for 2 Bitcoin, and then you have the total amount output for 3 Bitcoin, and so now this little extra amount gets burned. So you have some way of essentially adding fees dynamically, and you can pick whatever other output you want, and then this will help you, like do this transaction. So another concept which I think is popular in the Lightning community is like this notion of anchor outputs. I've been calling them gas outputs. There's maybe some differing terminology that needs to be sort of unified. But the idea is that you have your main contract, which is paying somebody 1 Bitcoin, and then you add another output, which is paying 0 Bitcoin or paying like a small trivial fee amount, and then you just create both. And the incentive for doing this, rather than just using child pays for parent off of the main UTXO, is this main UTXO, you might want it for something. So you might say like, no, look, this UTXO is like some other contract. I can't just spend directly from it. So instead, I'm going to create a UTXO that I don't care about, that I can use outside the state of my contract that I actually care about just to drive fees forward. And so what that looks like is now instead of spending from this 1 Bitcoin, which maybe has a time lock, by the way, like let's say this 1 Bitcoin was time locked for a year, then you really, if it's a relative time lock, there's actually not necessarily a great way for you to move things forward from this CTV. If you've got to wait a year, the mempool won't actually recognize it. So this 0 BTC output is able to be immediately spent and doesn't have the sort of time locks that would prevent it from happening. And so you kind of do the same thing that we did before, but now there's this unperturbed 1 Bitcoin output that we were trying to create that we're able to drive forward. Now, what's cool in Sapio is you are able to conditionalize some of these things and use a yield inside Python. And now what this says is if we're going to guarantee that either one of these 2 things happens, and so maybe we have some unlocking conditions applied to this branch, and we've got very similar transactions, but now we're saying either give us the one that has the exact Bitcoin output that we're trying to create, which is this one, or give us the one with 2 outputs and have one of them be devoted for fees. And so this gives you some more flexibility on deciding if you actually want to create this sort of gas output or not. So that's one way of using Sapio to structurally declare how you're going to pay for fees. Now, you can also do this sort of output trick at the input level. So you can say in Sapio, well, actually, there's just going to be an additional input that comes in here, and this is just going to be used for fees. You can do the same conditionalizing trick where you say, we either want the form where there's some extra input, or we want the form where there's no extra input. So there are a lot of different ways that you could try and solve fees, and you can use them together in different ways. It can get a little bit confusing because not necessarily like any single method is the right answer. It really depends on what you're building. So here's like a general list of how you might think of like when different solutions are favorable or appropriate. So if you have a contract that involves nodes with relative time locks, then you really need to have these anchor outputs all along the way because the relative time locks will prevent it from getting included in the mempool ever. So you need to have these. Or you could also just pay high enough fees. Like if it's a short-lived contract and you think you're going to be able to drive it forward, just pay the appropriate amount of fees, and that will be good enough. If you need TXID non-malleability, so let's say you're using this in a Lightning Network context, you might prefer an unconditional form because it means you've got to sign fewer things that are less, variants of the contract that you're working with. For unconditional outputs, because outputs are non-malleable, whereas inputs are possibly malleable. If you don't care about malleability at all, then the conditional gas anchor inputs are relatively nice. It's like a pretty straightforward API for adding funds to a transaction. My overall favorite is the gas and anchor outputs. I think that generally this should be the way that the software evolves, that people should get support for this. But it requires, maybe some work from the community to make this work really well because you have issues around transaction pinning that have, kind of currently been a focus for the Lightning Network community. So we're gonna get back to fees in a little bit. This is just some basic context for like ideas of thinking about how contracts might pay fees. That pertains to CheckTemplateVerify or not CheckTemplateVerify. But now I think what's cool with Sapio is we can talk about composability and how contracts can work together. So Sapio as a language and a framework, who here has used React? People have checked out React. So you can really think about Sapio as being like React, but for Bitcoin script. And I'm going to show that to you by looking at another example and showing how this composes with what we worked on previously. And you'll get the idea that with Sapio, you're building kind of a component hierarchy where you can pass properties up and down the stack, and then you can determine functionality that way. And it gives you a really nice, composability way of defining how you want things to work. So this is a new contract. This is a return to sender. And so return to sender is kind of interesting. So what you have is you have a number of fields. There is a receiving contract, a receiving signal, a refund contract, an amount, and a timeout. And we have two different ways of proceeding. Either we can process a refund, and that refund happens after the timeout, and then that sends the funds back to the refund address, refund contract, right? Or if we get the receiving signal from somewhere, depending on what our receiving signal is, then we can move the funds to complete the transfer to the receiving agent. So does that make sense? It's basically like a acknowledged receipt. You send money to somebody, and then they say, hey, look, you sent it to the wrong place. Like, we don't want it. They don't send the receiving signal. Then you just take it back to the place that you specified. So it's sort of like a nice undo send functionality. It's not like a double spend because they have to explicitly claim the funds in order for the deposit to finish. So like, you can't steal the funds unless you let the timeout decay, but you don't credit the person's account until you've actually finished that transaction. So there's no like double spend, but it allows an undo send like functionality, kind of like Gmail, you mess up and you get to pull the message back. So what does this look like diagrammatically? So this looks like another one of these like little state diagrams that we had before. So what we have is we start by putting the funds from somewhere into this refund UTXO. And after a day, the funds could move back to our refund UTXO and with this little zero value output to use for a child pays for parent. So that whatever our contract is here below, we don't have to disturb it to drive this output. And on the other hand, we have a signal. And if we receive this signal, which is like some sort of arbitrary script condition, then we can move the funds to the receiver. So does that make sense to everybody? It's just basically like undo send functionality. Do people follow? Cool. See some thumbs up. Okay. So now let's compose this. So this is where things get really freaking cool. So before we talked about the federated peg-in. So we had this liquid federation peg-in mechanism, and we were saying, okay, well, here's all it takes. But what happens if you sent money to the federation and they said, that's not our federation, that's like the wrong thing. Like this is like a completely different contract and you didn't send it in the right way. You generated this contract when you sent to them, but maybe you messed it up. Well, now you can wrap it inside of a return to sender. So you take this return to sender contract. Let me grab my pointer again. So you take this return to sender contract and you pass into the receiver this federation peg-in. And for the receiver signal, you require a threshold of everyone to agree that the funds were appropriately deposited. So now you have a way of saying, like, the funds only complete the peg-in if the federation actually recognizes with a commissive act, like they intentionally took the money into the federation. If they didn't intentionally take it, then they couldn't take it. This can create a better sort of legal framework for transfers like this, where if you sent money to the federation, they said, oh, look, we changed the thing on our website you sent to the old one. Then you'd be like, okay, well, like, how do I get my money back? They'd be like, we deleted the keys. And you'd be like, well, like, don't you legally have the right? It's like, well, you didn't acknowledge it before you tried to send it to us. So no, it's kind of like you're bad. With this framework, you can kind of permanently embed a layer where there's an ability to undo the transaction or move it forward so that you don't run into situations where maybe a stale federation permanently freezes funds. You have the ability to make sure the federation is live before the live on chain with like an active thing before the funds actually move. So this protects you against a whole new class of vulnerability. Now, this is a lot of complexity going on, but we can still do the same thing that we did before, which is unroll it into a diagram. And so now you start to see the power of Sapio, where we just, previously we had this arrow coming from nowhere for this peg-in, but now we can see that we want the arrow to be coming from an undo send. And we didn't have to write those as two integrated pieces of functionality. We wrote the undo send contract, and generically we were able to plug in the federation code, and then it works. That's pretty cool. Like, who thinks that's cool? I get super excited when I see this. Yeah. So, and all the state diagram, once you've transitioned to the state, it operates the same as it did. It doesn't know about this like prior state. now you'll notice that I've added here something that wasn't in the previous diagram, which is this little zero output, right? And this zero output is here too. So we've added into our contract definition just for showing you the fees. I'm not going to show you the contract where we add the fees because we showed that a few different times, but we will talk about how this actually ends up working in practice now, because now we've got a sophisticated contract and we want to understand how fees get paid. So we'll take another look. So here it is without without any fee harnesses added to the federation. So this is all we're adding. So it's pretty simple. We're just adding that. So okay. So the state that we want to get into to claim the federated funds into the federation is this state. We want to get rid of this sort of return sender functionality, right? So how do we drive that forward generally? So what you're able to do with these kind of gas outputs is you are able to, sorry, these pointers are very hard to pick up. I guess some things don't change in VR. Like, I don't understand why you can't just like finger gun the, like pointer. Like, why do I have to actually hold this thing? Okay, so what you're able to do is you're able to make a new fee transaction. So this fee transaction exists outside of the contract state of our main contract. So there's no sort of like dependency that any downward state has on this thing. And what we do is we claim these anyone can spend outputs into this, and then we add a new output that pays fee, and then we give ourselves some change. And so what this does is this drives forward the progress on this contract. And in this case, we're driving it forward to the case where, because we're claiming both of these, where the 2 of 3 has claimed, you just deposited here, but the federation is evil. So we want to claim all of the things to start the backup process, immediately, because this is a dead federation, and like maybe it's been a day and you haven't taken the money back, so we're just going to try and do it for you or something. I don't know exactly why you'd want to do this particular case, because you've got to then wait for 3 weeks. But like, let's say you wanted to just drive the contract forward this much. So then, what's cool about this is atomic. So I mean, so we did this, and then let's say it confirms, and this has driven the contract forward to this point. Let's say somebody else came in and did a different fee transaction. So now we have some other fee transaction here, but note that it's like both of these transactions paying fee are claiming the same output. So it's sort of like you've got like the Harry Potter duel going on, like, neither can live while the other survives, right? So one of these has to be the actual end transaction that gets confirmed. It can't be both. So let's say this one pays higher fee, this new one coming in. So it actually kills the other transaction. So this other fee paying one gets killed, this one goes through, and now this one is sort of orphaned because one of its inputs is dead. This might seem like a bad thing. You're like, well, I just tried to pay fee, but actually, if you think about it, when you tried to pay fee here, you were overpaying because you were trying to pay for 2 different state transitions within the contract, and now it's been orphaned because somebody else paid for it. You only need to pay for one. And so you can now reattach a new transaction onto here, which just claims the individual state that you're interested in driving forward, and then creates a new change. So you get more money back. So you can kind of have up this tree of gas outputs. You can optimally claim money in a multi-party context. Like anybody can claim whichever state they're interested in and pay enough fee that they're going to be the best bidder. And then when you're trying to atomically claim all of the actions that you're interested in, you don't end up overpaying because they'll evict your payment. There are ways of cooperating so that you can work together to pay, but right now the mempool does not recognize all of that rational behavior. So it doesn't completely work with current mempool behavior. Does this make sense as like a general, like you have not only these contracts, but you have a way of driving forward the execution by paying fees external to the actual logic of the contract that you're interested in. That's really the critical idea. You've separated out the control logic from the value logic, which previously you have to update lots of logic internally to change the amount of fees that you're paying, which as any developer knows is like a nightmare. So now that we've kind of finished that story on fees, I wanted to show you the composability because it gives you a more interesting example to work with before we finish the fee conversation. Let's talk about how software engineering might proceed in this space in order to develop high quality Sapio libraries. So previously we had the return to sender contract just receive an arbitrary contract. But what if instead we say that it receives a contract protocol which has an abstract method, which means that it's not implemented, it has to be implemented by a subclass. So if you subclass this signaling contract, or if you implement it, then you have to implement the functions that are listed. So let's assume we have that. And now it says it's a signaling contract, so it has some method called signal. So what we're able to do is we're able to replace down here where we previously had this field for signal. Now it's just like replaced with calling the function signal on that contract. So then what we do is we take our create peg-in contract and we get rid of the idea of having a signal. So now there's no signal in here. We just have a federated peg-in contract, and we added a little bit of code, which is just a signal function to that federation peg-in, which is called signal, and that returns the threshold for all the keys for 11 out of 15 of the keys. And now return to sender basically automatically learns to like talk to this functionality. So we're able to have, and this is where I'm going with like that things are like React, a little sneak preview, I guess that's what I'm going to say, but like you have a sort of system of passing props up and down between contracts and generating functionality automatically and linking them together. This can be like tremendously powerful. It's a lot like React. It's not as mature. React is like, used in industry really widely. But I think over time, we're going to be able to build out a contract programming environment which has a lot of reusable components, a lot of software infrastructure and support for those components and how you integrate them into applications. And Sapio is going to be that integrative layer where people are going to be able to hook in and use as a plugin for building smarter applications on Bitcoin. Now, the next 1,000 slides are actually missing from this presentation. Udi deleted them. What a jerk. Because there's just way too much. Udi didn't actually delete them. He's a nice guy. I didn't want them here. Like, there's so much we could go in depth on, and I think this is already like an overwhelming amount of stuff. Like, if we had Sapio 102, like the next things that we could talk about would be the UX layer that I built. There's actually a UX that I'm working that gives you sort of like a bare bones development, debugging, and usable thing if you wanted to like start using these contracts. Like you can just click button and like deploy stuff to the network and like drive transactions forward. It's in progress. It's pretty cool. We would talk about more specific contracts. We only looked at federations. We only looked at like Blockstream, like liquid federation, peg-ins. We could look at secure wallet vaults. We could look at congestion control. We could look at all those things that we talked about before. There's like so many things that we could spend hours on just a single contract. But we're limited in time, and I wanted to give you like sort of deep dive on one thing. So in the 102 class, we'll be able to do more. Talking about integrating Sapio into applications, what APIs you get, what ABIs you get, how do you actually interface with these components? How should that work? That's sort of a next topic. Advanced programming, you're actually able to embed a lot of safety principles and practices. There are ways that are sort of still in development around making assertions around when fees can be made, timing transitions between two different subcomponents. So there's a lot of safety analysis tools that I'm working on adding and paradigms that I'm adding. We can talk about the actual compiler architecture. You can just know that it works. And then managing contract state, it's kind of related to integrating applications. Like, how do you build this with watchtowers? Can you put stateful, things inside of these contracts that manage updates and things? The answer is yes, you can. And this could be a way of making, like a lightning implementation where each contract node is aware of the state it's supposed to be managing internally. But that's the next class. We're not going to talk about that today because we're already at 45 minutes, and there's a lot. But what we will talk about is like, what are the next steps? Like, what am I trying to do? So I need to improve language and polish it for open sourcing. Like, it's still like pretty rough around the edges. There's a lot of you would really need to understand in depth how the things work in order to be able to get building right now. I'm hoping that will change, and I know it will change. It's just a matter of development effort. I want to develop out this library of high-quality contract components so that somebody who's having their first experience with Sapio doesn't necessarily have to actually write their own components. They can just stitch components together like Lego blocks and get like really sophisticated functionality. That's why it's React-like, and that's why it's powerful. With React, you can just download React Bootstrap, and then you can plug things in together, and it's really simple. You don't have to build all the components yourself. improving all the developer ecosystem and tools is really important. CTV, I said earlier that if we don't get it, it's not a big deal. We can just do something else. It actually is kind of a big deal. Like CTV makes all this stuff really possible, and without it, it's really severely limited in what context you'd want to be able to use it, especially with regards to non-interactivity. So getting CTV adopted is really instrumental to making this vision that I showed you actually work. I'm looking for funding and grants. Is aspirationally like a completely open source and free project that anyone can use. I'm working on like so many different parts of the stack to get it done. I could really use help, and so I'm trying to build this organization, Judica, to bring people on to work on some of the problems that will be faced in bringing this functionality to Bitcoin. If you're a developer and you're like, how do we get started with this today? Well, you can tweet at me and ask for alpha access. I'm rolling it out to a limited number of people who aren't going to complain at me for things being broken. So if that's you, aren't going to complain and then might actually submit pull requests to fix things. That's sort of the key key thing I'm looking for. So if you want that alpha access and are interested in getting involved, or if you're interested in getting paid to work on it, you can DM me for more details and we can have that discussion around what sort of skills are needed and how you can contribute. All right, that's all I got for you guys. Sorry it was a short presentation. I wish I had a little bit more. I'm happy to open to a full Q&A now, and also happy to revisit any slides that people were sort of confused on and re-explain that if it landed flat. Thank you all very much.
That's cool. Sorry about deleting the last 1,000 slides, Jeremy. It was just too long. I had to. So guys, you should see on your bottom right corner of your screen, you should see a raise hands button, and you can click it if you have any questions to ask, or if you just want to say something, that's allowed to, and then I'll be able to let you speak. Don't be shy. It's your only chance. Okay, let's see. So we have a question from Ben. So go ahead, Ben.
Hey, oh wait, can you hear me?
Yep.
Yeah, I can hear
you. Great talk. That was really interesting. I'm curious, what exactly are you working on now? Like, what needs to be done with this to improve it more?
So if you look at the things that are on like the Sapio 102 slide, these are things that are all under really active development. So I could talk about what the engineering trade-offs are in this, and I have a lot of ideas and code written that's sort of experimental, but I don't have anything that I feel like crystallizing. So a lot of the work is in just getting everything end-to-end working. So right now, for example, I can emit a list of transactions, and sometimes you'll require a signature for a transaction, but I don't have the code to send that to your Ledger Nano for signing. I don't have the code for pulling 100 keys from your Ledger Nano for writing a contract. I don't there are a lot of components that just don't quite exist. That would be good. And then there's just security auditing and making sure that everything does exactly what it's supposed to do. There's a lot of performance engineering too. It's written in Python, and I'm replacing the functionality that I can with faster things. And there's a reason it's written in Python, and I don't think that's going to change, which is that you want this really powerful metaprogramming environment where you can stitch things together really nicely. I think it would be really hard to get that in another framework, and until the ecosystem is more mature, I'd be reticent to shifting the actual front end language for building these. And then there's just analysis tools. There's a whole lot to do. There's also work that exists outside of Sapio that's more CheckTemplateVerify and Bitcoin related. I'm working on rewriting the mempool completely. That's a long-term project that is really important. The mempool is not the best mempool that we could have. It's provably impossible to have an optimal mempool. So we know that we're never going to have something that's perfectly rational. But the one that we have right now, there's a lot of challenges for anybody doing smart contract development, especially Lightning. So making that better is going to be is a really critical task that like I am spending actually a lot of time on. Like I'd like to be focused completely on Sapio, but it turns out that like I'm one of like a few people who deeply understand the mempool. I'm working on that as well. And then there's other more general like wallet integration and just integration whatever things that need to be done. So there's a lot, and just getting CTV merged. Like I'm doing a lot of work to convince people that it's a good thing. This is part of that work in saying like, hey, if you like want this, like you really have to like push for getting CTV because we're not going to be able to do it unless we get that kind of functionality. So, that's sort of maybe, I don't know if that answers your question.
No, that definitely does. Thank you.
Yeah, the answer is a lot.
Great, thanks, Ben. By the way, Jeremy, I'm not sure if you're aware, but you're kind of behind the screen. Maybe you're just being shy. But
well, like generally, I'm not aware, but of that, I'm not aware. Okay, no, I think I'm
cool.
I'm good.
Let's see. So next question from BTC Kitty. Go ahead.
Hi. So when do you think the CTV will get merged?
Tomorrow, actually. No. If you ask every developer when, you'll get like a very different answer. I think that we probably need to have like a real honest like community discussion around ossification and like how changes get staged and prioritized and accepted and what trade-offs we're willing to make in that process. There are a reasonable number of people who think that it's 3 years from now, at least. And I think that that's sort of like very sad in that if it's 3 years from now, like that's hard. Like it's really hard for me to like make the case that this is important stuff to work on if it's not even going to be, really usable until at least 3 years from now. And some people are like, I don't know, just like ship it and like, let's see if we can get it in 6 months. I fall more in that camp. I think that like personally, the default thing that happens with Bitcoin, people are worried about ossification in that like maybe ossification kills Bitcoin. I think the default thing that happens in Bitcoin is it dies. And so because I think that the default thing that it happens is that Bitcoin dies because like, we've got, like a big, fish swimming behind us that's going to swallow us. Like, I think we need to be going as fast as possible in order to do that. But there are people who also, say that, well, like, no, really, we want to make sure that we're going in the right place so we don't swim into the big fish and get eaten. So, there's two different sort of concerns around like how Bitcoin might die. I fall more in the camp that like Bitcoin is so far in its early stages and experimental that we need to be pushing really quickly. Other people feel that Bitcoin is more ossified and needs to move really slowly. And that's something that, if you believe in like Taleb stuff, there's like this intolerant minority thing, which is that, like people who are want things to happen really slowly might be the intolerant minority that just like blocks progress. But from my perspective, that looks like an attack on Bitcoin. Like if we have such slow progress that like we don't deliver a lot of these tools to people, like Bitcoin, in my opinion, dies. And so I model like, Bitcoin should take 10 years to do anything like this is like death by committee. So it's a difficult question. I don't have like an answer of like when something specifically is going to happen. I would like to see it happen sooner than later. I think that we didn't talk about vaults that much. I mean, the Liquid Federation is kind of like a vault, but vaults I think are one of the most important use cases that CTV is going to bring to the table. And what I really like about them is they bring an immense set of self-sovereignty financial tools to a really wide audience. It's really cool that you could say like, I've set up secure storage for my Bitcoin and it sends, like an allowance to my phone. And if I wanted to get the funds, like moved off my phone, like I have to go through some backup process, but I have no provider who's doing that for me. I'm just doing it myself. Being fiscally self-sovereign, I think is like the aspiration of Bitcoin, as much as being scalable. And so I think delivering tools like CTV sooner that like allow us to achieve even moderately better results, maybe if we have a longer term thing that's even better, I think we should do those things now. And I think we need to accelerate that work rather than, wait, 10 years for the perfect design that solves this forever. Because that's going to be waiting for a fully zero knowledge EVM that runs in O of 1 all the time. And maybe we'll get that, maybe that happens at some point. I just don't think it's yet. So that's all I got for you.
Cool, thanks. Let's see. So we have another question from Waxwing. So go ahead.
Hi, can you hear me?
Yep.
Yes.
Hi, yes. Sorry to drag it down to the such a low level after the sort of higher level stuff. I'm wondering, it might be that some other people find this question useful. Just thinking like the very basics of what we're talking about, opctv and BIP 119, right? Now, I guess a lot of people won't read the bit, but can you kind of like summarize really simply, or not simply, but just summarize exactly what gets controlled? So somebody, you create a UTXO, and the idea is that there's some control over the transaction that spends that UTXO. Could you kind of list for people like what exactly can be controlled? You've already mentioned examples, like it could be amount, it could be the output, whatever, it could be the input. Like what exactly can be controlled, and what were the design decisions about what can and can't be controlled in the spending transaction?
Yeah, so I think I can answer concretely. The way that CheckTemplateVerify works is you take the hash of everything that affects the TXID, except for which outputs specifically are being spent. So that's all of your outputs. That's all of the script sigs, but not the witness data. That is how many outputs there are, all of the sequences. So like what time locks you have, your time lock, your version. You hash all that together, and then you just put that in the script, and then that's what gets played forward. Only if the transaction matches those concrete details is it allowed on the network. That's like a little bit abstract. I think it is maybe a little bit easier to just like think of it in terms of this like very small Python function up here, which is that like given a transaction template, you can get a key. And once you get a key for it, it's always going to be the same key, right? So that's a hash, right? It's this is an oracle that's emulating CheckTemplateVerify. So you guys have a key, and then you can request that it signs a transaction. So all you do is you say, okay, well, like, let's check that we've already registered this transaction. We've already computed the hash, and check that the transaction template matches the exact transaction. So if that happens, we've asserted this is true, then just return the signed transaction. So basically we're saying create a key that can only sign off on a specific transaction, and then allow getting that signature. So that's like the basics of what CTV is doing, like sort of metaphorically, but like concretely it's using a hash instead of this oracle. And then that breaks sort of like cyclical problems of like like you put the key in and the key is generated from the transaction, and it's a random key. It's and we're just willing to sign only that specific transaction that was registered with us for that key. Does that kind of answer your question, or were you looking for something else? Oh, maybe you need to raise your hand again.
Sorry, yeah, it's Udi's muting me. No, yeah, I was asking as much for other people as for myself, and it's just a question of like, you've got to read into the details. But I was just I think that's pretty good high level idea of what it's doing. Yeah, thank you.
Yeah, there's if you go to utxos.org, the BIP is linked, and you can see exactly what it's doing. It is not, so like there have previously been covenant proposals, which you could describe with maybe a similar emulator as this. Really, it's just a very simple hash check. So there's not that much sophisticated stuff that you can do. It's very similar to what already happens with the signature in terms of what gets hashed. It's just whether or not you can change what you signed after you create the UTXO. With this, it's like a signature that you commit to inside of the coin, which I think you used to be able to do. You used to be able to do CheckTemplateVerify in Bitcoin, possibly, but then we removed some certain features. I think that made it not possible. I'd have to double check that. That we used to be able to do delegation. I know. I'm not sure if you were able to do CheckTemplateVerify. So Yeah, it's not terribly complicated. Other covenant proposals, like you've got like more like introspection and stuff. This is just like a quick and simple, like check the hash matches, and if so, proceed. If not, it's not a valid spend. If you have opcat or other functionalities, then you get to do more sophisticated stuff. But we don't have those, so it's not super worth looking into. But there is sort of an upgrade path for CTV if we wanted to get more complicated functionality in. Like opcat would allow you to do like very, very sophisticated contracts.
Thank you.
Cool. Okay, I don't see any other questions. If anyone wants to quickly raise their hand, I can let them ask a question. No, it seems like that's it. So, Jeremy, thanks a lot. That was cool. It was pretty interactive too. I like that you stopped to let people. Yeah, people seem to be happy.
Thank you.
Yeah. I don't know why I have a screen stuck in front of me. Oh, I fixed it. Okay, cool.
Yeah.
So yeah, thanks, Jeremy. This was awesome. And yeah, also thanks to Ben and Andrew who were helping out behind the scenes. And yeah, don't forget we do this every week. So you can follow us on recklessvr.com or reckless_VR on Twitter. And we have the Reckless VR Telegram group. Actually, so every week we were jumping after the talk, we're jumping to VR chat, which is kind of like going out for drinks after a meetup just in lockdown. So we're going to do that. And I'm going to send the instructions on the Telegram channel in about 20 minutes. And until then, you can stay here or you can take a break. And yeah, this is it. So yeah, see you next time. Oh, by the way, by the time we're here next week, there should be like a new avatar system, which is pretty cool. So this is nice. This is maybe the last time that we'll be able to see each other in this pretty disgusting form. So that's cool. So yeah, just so you know. And yeah, thanks again, Jeremy. This was awesome. And I'm gonna unmute everyone now. So yeah, unfortunately.
Yeah. Thanks for having me on. I really appreciate getting to get a VR talk, and let me know when we can do 102.
For sure. You can speak.
What up? Do you have a ghost in real life?